Hey, welcome back, chemistry students. We are on our last part of covalent compounds. Open up Unipacks. I'm going to share my screen. Let's get started. So in part one, we looked at how the bonds are formed: single bond, double bond, triple bonds of a covalent bond sharing electrons of nonmetals. In this lesson, we're going to examine the properties of covalent compounds and determine names and formulas of covalent compounds. Open up Unipack to page 30. Let's get started. So first, let's go back and review the covalent bonds. A covalent bond is a chemical bond that involves the sharing of electron pairs between non-metal atoms. Covalent bonds occur only between the nonmetal elements. These electron pairs are known as shared pairs or bonding pairs. And the sharing of electrons allows the nonmetal to bond and become stable, forming a molecular compound. And so covalent bonds are also known as molecular bonds or molecular compounds. And here we have an example of the hydrogen atom. And remember, hydrogen is a nonmetal, even though it's all the way on the far left of the periodic table. It is a nonmetal. It only has one electron, but it's going to need two to become stable. And so hydrogen is going to form a shared bond with hydrogen, making H2, making the hydrogen molecule. So let's talk about the properties of covalent compounds. Remember, the properties of covalent compounds are made up of nonmetals sharing an electron. The molecules can be either solid, liquid, or gas. Remember, different elements, whether they're metals or nonmetals, will have different states that they can be in. They can be a solid, a liquid, or a gas, depending upon the temperature that they're at. Now, covalent compounds typically have low melting and low boiling points. So they don't need a lot of heat to be melting or having boiling points. Now, the other thing about a covalent compound is covalent compounds cannot conduct electricity when they're dissolved in water. So once they get dissolved in water, they can't conduct any electricity. Let's go back and review ionic compounds for a moment. And it's always good to compare the ionic compounds to the covalent compounds so you can get a real good understanding as to what those differences are. Remember, the ionic compounds made up of a positive metallic ion and a negative non-metallic ion after the metal transferred the electron to the nonmetal. And they're typically arranged in a repeating pattern called crystals or a lattice image. And therefore, they tend to be solids. So your ionic compounds can also be crystals. And they have very high melting and boiling points. And so if we take sodium and chlorine, chlorine being a nonmetal has a very low boiling point. But sodium has a high melting point. And when they combine together to form sodium chloride, their melting point is extremely high. It takes an enormous amount of heat to take that salt crystal and liquefy it and melt it and get it to boil. Now, ionic compounds can conduct electricity when dissolved in water. So how do we determine the name for a covalent compound? And we've done this before with the ionic compounds, but now we're going to look at how we're going to name a covalent compound. So we give you the formula, and then you need to have the name. Well, you're going to name the first element with a prefix to indicate how many of that element you have. We're going to give it a numerical prefix. Now, the exception, of course, is if there's only one, you're not going to use mono for the first element. Then you name the second element with a prefix to indicate how many, and then you add that IDE ending. Let's take a look. First, there's some prefixes you need to know. And so what I'd like you to do is I'd like you to add this into your notes pack, put it on the left-hand side in the margin there, and make a little table for it. And so if you only have one element, it could be mono. Unless it's the first element, we don't call it mono. Di is for 2, tri for 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona is 9, and deca is 10. So you can add this into your notes, but also put it on your periodic table or put it on your polyatomic ion sheet. You'll be able to use those notes when you're working on your assignments. So let's leave this up here for a moment while you get this down. Remember, mono is 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8. Hey, remember the octet rule? Got to have 8. Nona is 9 and deca is 10. So for example, let's name the compound of P2O5. Well, this would be diphosphorus, because I have P, which is phosphorus, and there's 2 of them, so it's diphosphorus. And I have oxygen, and I've got 5 of them, so it's going to be diphosphorus pentoxide. Diphosphorus pentoxide. And you can also go backwards. If you see phosphorus, I know I've got P, di is 2, P2, pentoxide, oxide is the second word, oxygen, pent is 5, O5. P2O5, diphosphorus pentoxide. So here's some practice. What I'd like you to do is I'd like you to write the name of the covalent compounds based on the chemical formulas below. And you have practice space right here on page 31. So let's look at these together first before you work on them. And let's make sure that we're working with a covalent compound. The first one is carbon and oxygen. Those are nonmetals. It's covalent. Second one, hydrogen and oxygen, nonmetals, covalent compound. Carbon and hydrogen, nonmetals, covalent. Phosphorus and chlorine, phosphorus and oxygen. These are all covalent compounds. So you can pause the video with this up on the screen and do these practices, and then we'll come back and we'll check them together. All right, let's take a look at what we have here. CO2, that one should be pretty easy because we talk about that one fairly often. It's carbon dioxide. Now, we wouldn't call it monocarbon because we only have one of them. It's carbon dioxide. The single element is assumed. Next one, H2O. This one's fun. Dihydrogen monoxide. Remember, you can use the mono on the second or the third element. CH4, carbon tetrahydride. tetra for 4, hydrogen hydride. Remember, you add in the IDE ending at the end. Next we have, looks like it's phosphorus and chlorine. And this is going to be phosphorus trichloride. And to help you out, you can just put a little slash between here so you can remember that it's trichloride. You wouldn't put a dash, just phosphorus trichloride. Then we've got this big one down here, which is going to be tetraphosphorus, tetra for 4, deca for 10, deca oxide. Tetraphosphorus dexaoxide. Now, just for some fun, next time you're sitting around the dinner table and you want a glass of water, why don't you ask someone, hey, can you bring me some dihydrogen monoxide in a glass with some frozen dihydrogen monoxide? They'll look at you kind of funny, but then you'll giggle because it's just water. All right, now, how do we determine the formula for a covalent compound? I give you the name and you break it out to the formula. And we've done lots of these with the ionic compounds. We're going to do some more of them here with the covalent compounds. Well, the first thing is you use the prefixes to determine what the subscripts are. Just like when we work with dihydrogen monoxide, di is 2, I've got H2. And since the oxygen is a single, it's a mono, and there's no subscript at all. So use the prefixes to determine the subscripts. There's no crisscross or simplifying in covalent. All we're doing is using the prefixes to determine the subscripts. So if we look at the formula for dichlorine monoxide, let's break this up together. Di is 2, chlorine is going to be Cl, monoxide, 1 oxygen, it's going to be Cl2O. All we're doing is going from the name to the formula. So here's some practice time. And this is going to work on your notes pack. I believe it's on page 31. You can pause the video after I release you to work on it. And we're going to be working with dicarbon tetraoxide. Remember, use your little table to identify how many elements. Hydrogen monosulfide, pentaphosphorus trinitride, sulfur pentoxide, and silicon tetrafluoride. So put the video on pause now and determine the formula of these covalent compounds. All right, welcome back. So what do we have here? Dicarbon tetraoxide, C2O4. I've got my carbon, di is 2, tetra is 4, oxide is oxygen, C2O4. See how simple these are to do? Hydrogen monosulfide. It was pretty easy. There's no subscripts at all. The first item is just hydrogen, single hydrogen, sulfide, sulfur, a single sulfur, HS. Pentaphosphorus trinitride. Penta is 5, phosphorus is P, so P5, N3. Here we have another one, sulfur pentoxide. Well, there's no prefix in front of sulfur, so it's going to be a single S, right? And pentoxide, penta is 5, oxygen is O, so this is going to be SO5. And again, you're looking at these, and these are non-metals. Then we got this nice one down here, silicon tetrafluoride. I think tetra is 6, so I'm going to have S FL6. Whoops, no, tetra is 4. My mistake. See, even if you work with this stuff all the time, sometimes you forget. That's why having that little chart is going to be helpful for you. So silicon tetrafluoride, SiF4. All right, let's review covalent bonds. Covalent bonds are made up of nonmetals sharing electrons, and they're molecules that can be solids, liquids, or gases. They have low melting and boiling points. They cannot conduct electricity when dissolved in water. And covalent bonds are named with prefixes to identify the number of atoms of each element in the bond. And so here's an example, our friend dihydrogen monoxide. Well, that's H2O. 2 hydrogen atoms, 1 oxygen atom, sharing those electrons. You use the prefix to determine the subscripts, there's a typo in there, when writing the formulas. So here we have our friend dicarbon tetraoxide, C2O4. So it's pretty simple to do. You just have to remember the process to get there. Now, after you update your notes, I'd like you to open up assignment L4 on covalent bonds and check your knowledge on that. Remember, use your periodic table, use your polyatomic ion sheet, use your table chart for determining prefixes. And then after you do that, in your unit pack, there's a few assignments in there that we're going to also practice in class, but you can start working on those, 33, 35, 37. Well, that's all I have for you on this lesson. This will complete our unit on bonding. Then we're going to get into reviews and get ready for your final exam. I'm Mr. Silverstein. That's all I have for you today. If you have any questions, make sure you email me or send me a message on Google Classroom, and I'll get back to you quickly. You guys have a great day.